Okay, so today, guys, we are talking about the special solutions of linear equations, okay? Of systems of linear equations. So basically what we've seen so far is we've seen a lot of examples where we would get an x and a y value and we would get one solution, right? Where two lines intersect at exactly one point, okay? So draw a dot where these two lines intersect in that first example and put they intersect at exactly one point. At a point. Okay? So when they intersect at a point, we have one solution, and it is the coordinates of that point, an x value and a y value, that satisfy both of the equations. In the second example, this is showing me that I have no solution. Why would I have no solution in the second example? Natalie?
They're parallel, they never intersect.
Very good. If the solution to a system is where they intersect, do these guys ever cross each other? No, so because they never intersect, we get no solution. Now, Natalie said something interesting about these two lines. She said that they were parallel. What does that mean for lines to be parallel? Andrea? Excellent. So anytime you have the same slope, okay, they're going to be parallel as long as they're not overlapping, okay? As long as they're not overlapping. Now, look at the third example. It almost looks like there's only one line drawn, right? Because both of the lines are the exact same thing. Why would that have infinitely many solutions? Why would two lines that are right on top of each other have infinitely many solutions? AJ?
Because they cross every single point.
They cross everywhere, okay? So they intersect everywhere. Or not everywhere, excuse me. At all their points. Okay? They intersect at all of their points. Now, what would need to happen for the two equations to lie directly on top of each other? What would need to happen for the system to have both equations be directly on top of each other? Yep. Excellent. The equations need to be the same or some derivative of each other, right? So they need to have the same slope and the same y-intercept, okay? Keep that in mind as we do these problems, all right? So let's take a look at example 1. We're going to solve the system of linear equations. It does not tell us what method to use. We can use whatever method we would like, okay? So take a look at the first one. What do you think about this set of equations? What do you guys notice? Yeah, AJ? They have the same slope. How do you know that they have the same slope? Yeah, they both have a 2x. But what form is it in so we know what the slope is? Andrea? Excellent. It's in slope-intercept form. So they have the same slope. And if they have the same slope, what do I know about the two lines?
They're parallel.
They're parallel. Now, you have to be careful, right? Because they could be parallel but also be right on top of each other. Are these two lines on top of each other? Why not? The y-intercepts are different. So if they're different y-intercepts, but the same slope, and they're parallel, will they ever intersect? Will they ever intersect? No. So how many solutions am I going to get? No solution. Okay? Now, I want to be very, very clear and tell you that you do not have to make these assumptions and you can still solve this problem. So please bear with me, guys. Copy the problem down again, a little bit further down, and write it y equals 2x plus 1 and y equals 2x minus 5. Let's say you did not graphically understand what both of these equations were doing. I want you to pick either substitution or elimination, and let's solve this problem and see what we get. Alfonso, which one do you want? Substitution or elimination? Substitution. Okay, so in substitution, what do I do to solve this system of equations? Yeah.
You add the equations.
You add them? That's elimination. What do I do in substitution, Karen?
You take the one of the equations and you plug it into the other one.
Good. So I'm going to take this top equation, which is solved for y, and I'm going to plug 2x plus 1 in for y in the second equation. So it's going to read 2x plus 1 equals 2x minus 5. Now we have an equation in only one variable, which is x. Let's solve it. Kyra, what would you do here?
Subtract 1.
Subtract 1. Perfect. Uh-huh.
And you times off the x. And I just get 2x equals 2x.
2x equals 2x.
No.
And then we just have to do the negative 5 minus 1.
Minus 6.
Minus 6. Okay. What would you do next?
Cancel out the 2x.
Good. So subtract 2x from both sides. What happens here?
We cancel out.
So I have 0 equals 0 minus 6. Is 0 ever equal to negative 6? Is this a true or a false statement? What happens when we get false statements at the end? No solution. So guys, do you see how we got no solution regardless of what method we use to solve this problem? Okay? You do not have to recognize that the lines are parallel. If you go about solving this problem with using any method, and if you use elimination, you'll get the same thing. Yeah, Mia.
How do you know, like, for the substitution, how do you know when to plug it in for y and when to plug it in for x?
Depending on what's already solved for.
So if it said, for example, x equals...
Yeah, if it said x equals 2y plus 1, then you would substitute this in for x in the second equation. Does that make sense? Okay. Yeah, McCarvin. Yeah, go ahead. Yeah, David.
So if we was to put in, let's say, instead of that y was there for x, we would put parentheses next to the 2.
If you were substituting for x. Any questions on this first example? Does Mr. Jurko care which way you use? No. If it doesn't say what method to use, you can use whatever you want, okay? Number 2, or B, excuse me. All right. One of the equations is in slope-intercept form, the top one. What is the second equation in? Yep.
Oh, wait.
What form is the second equation in? Yeah?
Oh, wait.
Standard form. Okay. So, what do you guys want to do? We can use any method we want to solve this. Yeah.
Can we do the second one, not the substitution, the other one?
Elimination?
Yeah. So
Sure. We can do elimination. But we can't do it right now. Yeah.
For a question like that, like, just for example, for substitution, how would you know, like, when to plug it in?
So we could also use substitution. You would have to substitute this y.
I would have to pick that one.
No, you don't have to. This one said you could use any method. You could also change this one into slope-intercept form and solve it that way. Natalie said elimination. We did substitution for the last one. I'd prefer if we do elimination for this one. But Mia, you can use any method that you
I
want.
was wondering because you said that it had to be x, but there's like x and y are both equal. So,
But you could substitute this y, which is negative x plus 3, in for y here. Okay? All right, so let's go ahead. In order to use elimination, we got to change this first equation. So let's rewrite it. It's y equals negative x plus 3. How do we change this equation to also be in standard form? Natalie?
well, you can add x and then add it in front of the y, so then they're line up.
Good. So it's going to be x plus y equals, these canceled out, and we just have 3 now. The bottom equation, we just copy it down underneath. It's 2x plus 2y equals 4. So this is our new system of equations. They're the exact same equations, just we manipulated where the x and the y were. Is there a match, Salucci? There is? What matches?
No.
Can we create a match for ourselves, Michael? How? You don't know? He's on the right track. He said that we can create a match, but how? Caitlin?
by multiplying by negative 2
Excellent. To which equation?
to the x plus y.
Good. Multiply the top equation by negative 2. When we multiply by negative 2, I'm going to get negative 2x plus, minus 2y equals what? Negative 6. Then I have on the bottom one, it's 2x plus 2y equals 4. Are you guys with me? Okay. What do I do next? I have a match, and they're lined up. Alec?
You put 2x to the other side of the equation and simplify it?
Not yet. No. Andrea?
Both of them cancel out, so then 0 equals -2.
Good. You add these two equations together. Once you get that match, Andrea, as you were saying, we add them together, so now things will cancel out. These cancel out, these cancel out. This whole side becomes 0. What's -6 plus 4? -2. Is 0 equal to -2? No. How many solutions do I get? No solution. AJ?
At the beginning, could I just change the second equation to y equals mx plus b?
Absolutely. Did you guys hear what AJ just asked? He asked, at the beginning, couldn't you just change the second equation into y equals mx plus b form? Absolutely. Whatever works for you. I just did a problem graphically, by substitution, and by elimination, and all of them gave me no solution. Does it matter which method you pick? No. Whatever method speaks to you, fall in love with that method, okay? Now, some of the problems will tell you you have to use a specific method. If it's that type of a problem, you can't use elimination for a substitution problem. Got it? You have to know all three methods. All right. Any other questions on A or B? Okay. Next example, we're going to example 2. In these examples, we are going to get infinitely many solutions. So it's on the next page. We're on letter A. Infinitely many solutions. Take a look at letter A. What method speaks to you in letter A? What method speaks to you for solving this? Karen? I agree. Elimination speaks to me. Okay? What would you like to do, Karen, to solve this? Because there's no matches, though. Okay?
So, you would have to add, for the first one, add -2.
Wait. Oh, are you looking? You're looking at C. I'm on A for the next set. I agree it's elimination here. Karen, what would you do for A?
I would multiply the first equation by -2.
Good. Multiply the first equation by -2. Let's do that. -2 times -2x is going to give me positive 4x. -2 times positive y is going to give me -2y. And -2 times 3... -2 times 3 is going to give me -6. Then we have -4x on the bottom, positive 2y, and positive 6. Caden, do I have a match? With what? All of them, okay? So we just add these together. Caden, what do I get? 0 plus 0 equals 0. Guys, does 0 plus 0 equal 0?
Yeah.
So is this a true or false statement? True. What happens when we get a true statement at the end? Infinitely many solutions. Go ahead, Austin. Infinitely many solutions. Because 0 is indeed equal to 0. It does not depend on x or y, whether or not our solution exists, okay? If you were to graph these two equations, they would turn out to be the exact same thing. AJ?
So to get one solution, you have to get like the point that we did this.
Correct. To get one solution, you get a point. If you get a true statement, it's infinitely many. If you get a false statement at the end, there's no solution, okay? Now, one thing I want to highlight, when you get both of the variables to eliminate, when they both cancel out, automatically you should be thinking it's either infinitely many or no solution, okay? Yes?
How do you know when it's one solution?
If it's one solution, you get an x value and you get a y value. We didn't get either value here.
So you would get like 2 plus 4 equals 0?
Correct. Mm-hmm. Wait, no. Yeah, when you keep one of your variables. So do you see how x is canceled and y is canceled here? And they both became 0? This automatically means I'm going to get infinitely many or no solution.
Will it always be 0?
Will what always be 0?
Like when you get infinitely many?
If you get infinitely many, it'll be a true statement.
Okay.
It may not be 0 equals 0, but it'll be 4 equals 4, 7 equals 7, -3 equals -3. Okay? Good questions, guys. Any other questions? All right, let's do our last example and then we're done, though. Okay? We've got x plus y equals 3, 2x plus 2y equals 6. What method speaks to you for this one?
Elimination.
David?
Yeah, elimination.
Elimination? I agree. Okay. What would you do here for elimination, David?
Multiply by -2
Hey, there we go. Multiply by -2. To which one?
to the bottom. I mean the top.
The top one. Okay. Multiply the top equation by -2. What do I get?
-2x plus
-2 equals
-6.
-6. You're missing one thing, David.
Y.
The y. Okay. -2y. Then we write the bottom equation the same way. You just carry it over. It's 2x plus 2y equals 6. Seb, what do I do next?
Then you subtract both equations,
Okay.
and you get 0 minus 0 equals 0.
True or false?
True.
It's true. So, how many solutions do I get? Nick? Infinitely many solutions. Mm-hmm. How we feeling? Is this okay?
Yeah.
All right, turn these in. That's it.